Hi, welcome to our channel True Up. Do you realize how bad Huawei's condition has lately gotten? According to Gartner's 2021 Global Semiconductor Research Report, Huawei HiSilicon dropped out of the world's top 25 semiconductor suppliers on April 17 as a result of U.S. trade restrictions that have impacted China's total share of the global chip industry. HiSilicon's revenue decreased by 81%, from $8.2 billion in 2020 to $1.5 billion in 2021, a $6.7 billion reduction in sales, according to the paper. This is directly related to the U.S. sanctions imposed on Huawei. To get out of this bind, Huawei has announced plans to increase performance for processors based on older nodes. Huawei has invented and patented a chip stacking technology that claims to be far less costly than current chip stacking processes. The technology will allow Huawei to continue developing speedier processors using older mature production technology, perhaps allowing it to evade U.S. penalties. The only concern is whether Huawei will be able to capitalize on its discovery, considering that foundries cannot build chips for the business without a U.S. government export license. But Huawei believes it can, especially considering that this technology might deliver a performance increase for circuits based on earlier nodes that aren't subject to such stringent U.S. limitations. In other words, it allows Huawei to remain competitive. What advances has Huawei achieved in 3D chip stacking? Can it assist Huawei in developing under U.S. sanctions? That, and much more, is exactly what we will discuss today. We'll get into the specifics of the new technology later, but first, it's vital to understand why Huawei is creating it. Since the United States government blacklisted Huawei and its chip design subsidiary HiSilicon and now requires all companies making silicon to apply for an export license because all semiconductor production involves technologies developed in the United States, Huawei cannot access any modern node, such as TSMC's N5, and must instead rely on mature process technologies. To that end, innovative chip packaging and chiplet interconnection technologies in general, as well as 3D stacking in particular, allow the company to pack more transistors into its SoCs while maintaining competitive performance, according to Guopeng, Huawei's former rotating chairman, at a recent news conference. As a result, the company's investment in proprietary packaging and connectivity technologies, such as the one it invented, makes perfect sense. Micro-nanotechnology, as demonstrated by 3D hybrid bonding technology, will be the major way of extending Moore's law, was said. Because modern leading-edge process technologies are progressing relatively slowly, multi-chiplet designs in 2.5D or 3D packages are a general way for chip designers to keep throwing more transistors into their products while meeting their clients' expectations in terms of new features and performance, according to a high-ranking executive from Huawei. As a result, the previous chairman stated that Huawei will continue to invest in area improving and stacking technologies for in-house designs. The public assertion made at a news conference plainly suggests that Huawei intends to employ its hybrid TSV-free 3D stacking approach, or perhaps a similar and more mainstream method, for its next products. The major concern is whether the procedure necessitates the employment of any tools or technology that the U.S. government may consider cutting-edge and refuse to provide an export license for. After all, most of the fab tools use technologies that originated in the USA. However, whether a foundry would produce 3D chiplet packages for Huawei using the latter's proprietary process remains to be seen. But, at the very least, Huawei has a unique technique for low-cost 3D stacking that can allow it compete even without access to the newest nodes. Innovative chip packing and multi-chiplet connecting technologies are expected to become critical for cutting-edge processors in the next years. Therefore, many major chip inventors and manufacturers currently have their own proprietary chip packaging and interconnection methods. Chipmakers often employ two packaging and interconnection methods: 2.5D packaging, which allows for a high-density/high bandwidth in-package connectivity for chiplets sitting next to each other, and 3D packaging, which shrinks processors by stacking multiple chiplets on top of each other. However, because chiplets must interact and power must be given through TSVs, 3D packaging often necessitates quite intricate wiring. TSVs have been utilized in chip production for over a decade, but they add complexity and expenses to the packaging process. Therefore, Huawei opted to develop an alternative method that does not need TSVs. Huawei's engineers created a mix of 2.5D and 3D stacking, in which two chiplets overlap each other inside the package to save space but do not sit on top of each other like in traditional 3D packaging. Huawei's technique exploits overlapping sections of the chiplets to build a logical connectivity. Meanwhile, two or more chiplets continue to have their own power supply pins that are linked to their own redistribution layer, RDL, in a number of ways. However, while Huawei's patented method eliminates the need of TSVs, it does not appear to be simple or inexpensive to apply. Huawei's method entails turning one of the chiplets upside down before attaching it to another, or others. It also necessitates the construction of at least two redistribution layers to provide power. Example, 2 chiplets means 2 RDLs, 3 chiplets can still utilize 2 RDLs, as can 4, see the above gallery for details, which is not inexpensive due to the additional process steps. The good news is that one of the chip's redistribution layer can be used to link items like memory, saving space. In fact, Huawei's hybrid 3D stacking technology may be more general than standard 2.5D and 3D packaging solutions from other firms. For example, it is difficult to stack 2 or 3 power-hungry and hot logic dies on top of each other since cooling such a stack would be extremely difficult, which may ultimately mean compromises with clocks and performance. Huawei's technique increases the surface area of the stack, making cooling easier. Meanwhile, the stack remains smaller than a 2.5D packaging, which is critical for mobile applications such as cell phones, laptop computers, and tablets. It is worth noting that Semiconductor Manufacturing International Corp. (SMIC), with whom Huawei apparently hopes to build a fab, is similarly depending on innovative packaging and connectivity technologies as a strategy to avoid U.S. government sanctions. Because the firm lacks access to the production techniques necessary to create semiconductors utilizing sub-10 nm fabrication technology, innovative packaging and connecting approaches are also critical for SMIC. Other semiconductor contract manufacturers, TSMC, Global Foundries, integrated design manufacturers, Intel, Samsung, and even fabless chip developers, AMD, who have access to cutting-edge fab tools and process technologies, develop their own 2.5D and 3D chiplet stacking and interconnection methods for their clients or future products. As a result, Huawei is simply following the curve. Thanks for watching our video. We would appreciate it if you subscribed our channel and gave us a thumb. See you.